Hi, thanks for sending your question. If we are going to show that the segments joining the vertices to the midpoints of the legs of this isosceles triangle are congruent, we're definitely going to need a picture because this is a coordinate proof, so we need some coordinates. We're doing this for the general case, so our coordinates are just going to be general coordinates and they're not going to have any specific numbers in there. So as you can see here, I've drawn an isosceles triangle on the coordinate axis here with the y-axis going straight through this top vertex up here, the vertex joining the two legs of the isosceles triangle. What this means is that the y-axis is going straight through the center of this line segment. So over here, I'm going to have some x-coordinate a, and I'm on the x-axis, so my coordinate is 0. And on the opposite side, I'll be the same distance from the y-axis, so I'll be at negative a0. And up here, I've just given us an arbitrary y coordinate. Since we're on the y-axis, we'll just call it 0b. The next thing we need to do is to find our points for D and E, which are the midpoints of the legs of this isosceles triangle. To do this, we're going to need the midpoint formula. So I'm going to go ahead and to find the midpoint for CA or AC, I'm going to use that. So I'll take the second x-coordinate, and subtract the first x-coordinate. So it'll be 0 minus a, and that will be over 2. And then the second y-coordinate minus the first y-coordinate. So b minus 0 over 2, which of course simplifies to negative a over 2, b over 2. So let's go ahead and write that up here. Okay, the next thing we need to do is to find E. We're going to do that in the exact same way. We're going to use the midpoint formula. So we'll take the second x, 0, subtract the first x. 0 minus negative a will leave us with a positive a. Here, we'll put that up here. And that will go over 2. And then the second y-coordinate minus the first y-coordinate, so b minus 0 over 2 will just leave us with b over 2. So this coordinate over here is negative a over 2, b over 2, and this one is a over 2, b over 2. And our goal in this proof, if we're going to show that these segments are congruent, we need to show that they have, that the distance from B to D is the same exact distance as we get when we go from A to E. So we're going to need our distance formula to do that. So we're going to compute the distance from B to D, and we just notate that as such. And that will be equal to the square root of the second x-coordinate minus the first x-coordinate, so negative a over 2 minus negative a. So that would leave us with negative a over 2 plus a, and that'll be squared, plus second y-coordinate minus the first y-coordinate is b over 2 minus 0 squared. So just b over 2 squared. When we simplify this, we'll get the square root of a minus a over 2 is just a over 2. So we'll get, if we square that, we get a squared over 4. And then when we square this, of course, we get b squared over 4. If you want to go ahead and simplify that further, we will end up with 1/2 times the square root of a squared plus b squared. Now we're going to go ahead and follow the same algorithm to compute the distance between A and E. So the distance between A and E is equal to square root of the second x coordinate minus the first x coordinate. So it'll be A over 2 minus A squared plus second y coordinate minus first y coordinate. So B over 2 minus 0. And simplifying this again, A over 2 minus A leaves us with negative A over 2 inside this parentheses. And then, whoops, technical error. There we go. Okay, B over 2 squared. Simplifying that again, you can do the math and figure out that when we square these and when we take 4 outside of the square root, we end up with 1/2 A squared plus B squared. So the distance from B to D is the same as the distance from A to E. Therefore, these line segments are congruent. Thanks again for sending your question. This was a fun one, and I look forward to answering more of your questions using Snap Math in the future.